All of you, it's good to be here in Spain. Manuel had mentioned earlier, Latin America is where we experience much of our Spanish culture. Mexico, Central America, South America. We're very fortunate to have this rich culture. I, as a student of the classical guitar and other things, I'm very happy to be here in Spain again. So, very much appreciate the history that you have, which we don't have as much of that in Seattle. But one thing we do have, which, yeah, we're laughing because we just literally the city it's very new, brand new. It hasn't been there long, relative to your thousands of years. Anyway, one thing we do have that Julian mentioned is water. We get a lot of rain. So I've talked to a few of you who've been to our events in Redmond. If you do come to Redmond, we'd love to have you there. It is a beautiful place, and we are fortunate to have that resource of water. So I thought about that when Julian was presenting. So what I want to do today, my purpose of this presentation is to provide a bit of an overview of the SMB 2 and 3 protocols, some highlights from our new 3.1.1 dialects, which are coming with our new updates to Windows 10 and Server v.next. I'll mention a little bit about that today, but I'll also mention more I was asked in the demo session to talk a little bit about what is coming in Windows Server v.next and a little snapshot of that. You'll notice that one thing is not here in the background is something near and dear to Chris's heart, is CIFS and SMB1. They will not be mentioned today. In fact, one of the things you'll be hearing more is guidance along the terms of, and the purpose for these updates and the talks today is reasons why we're moving forward for things and concerns such as security and other capabilities, which is another means of saying to put those other things such as the SMB1 implementations and all of their issues behind us. So I'll also talk a little bit about the foundations that SMB3 gives us for what we are calling now software-defined storage. That's referred a lot in the industry, whether it be those of you who are in the OpenStack world. How many of you are following OpenStack? I know, yes, okay, some. I know here in Europe there's much going on in the OpenStack world as well as in the US. So the software-defined storage in our world of building the private cloud. So I'll talk a little bit about how all of these protocols really provide the plumbing for that. I do have a bit of an update on the Azure Files side. So for those of you who are interested, I can give you just a little bit of a snapshot of what that means for which is essentially another SMB2 implementation. There are some, as I mentioned with Michael, we'll be delivering some test tools, and so I want to give you a little bit more of an understanding of what we'll be providing from the Windows side of things, and a review of the resources that we are making available currently to you. So these are the things that I do want to take just a brief period of time and give you just an overview of a snapshot. So for those of you who have not followed the SMB2 rewrite, which was written, and the specification itself, MSSMB2 is the base specification. SMB3 provided some key capabilities, again, for the basis, the plumbing, underlying the storage infrastructure, transparent failover, some witness capabilities, and multi-channel transport that I'll give you a little bit more information about. Some performance areas you'll have seen, and for those of you, have any of you followed the SNIA Storage Networking Industry Association? I know Chris and Volker and others are participated, contributed, attended. There's a whole series of talks that various folks have given covering these areas, many of them not Microsoft in today's world, covering the SMB3 implementations. So performance, though, seeing the scale out capabilities in clustering, and then also SMB Direct, along with multi-channel directory leasing and some other capabilities that were implemented earlier with copy offload do give you some performance capabilities that really serve what needs to be done and give you the capabilities of building a private cloud implementation for whether it be in the OpenStack world or in some of the Microsoft worlds that you'll see discussed. We do have some references, and so off to the right side I've included several references to the remote VSS for some of the backup services. This, you'll see as always an MS dash in front of the specification name. And at the end of this presentation you'll be able to refer to the link to our open specifications libraries. So, and again, the security area, really the primary purpose to the updates, if there's any key primary purpose to the new updates in the recent releases for MS SMB 3, the 3.1.1 updates include security. Those capabilities we'll talk about a little bit more. The encryption, the signing, and dialect negotiation are really critical. Those are critical to the infrastructure and providing some level of deterministic reliability and security in the environment. And again, referring to the SMB2 specification, which is the base specification for the SMB3 protocol as well. Again, RDMA and multi-channel being your key areas for the transport and delivery at higher speeds, and some of those capabilities I'll talk about just briefly. And again, for availability, the witness protocol as well as the transparent failover for the clustering, again, are fundamental to the capabilities of delivering a cloud infrastructure. SMB Direct, just so that you're aware, I know that last year even at Samba XP, the IBM was underlying the sort of the critical nature of implementing some of these higher performance capabilities using a higher performance NIC, using these InfiniBand level deliveries, or even just the higher speed Ethernet. You know, those of us who remember back when we were using twisted pair and first seeing speeds of 10 megabits, and now talking of 10, 40, hundreds gigabits. So this is, the networking speeds are definitely improving at your physical layer and up at the transport using RDMA internally so that you can do the delivery locally on the system with a lower CPU impact between the server and the client in this case for delivering data. So this has been something that's been quite helpful for performance and dealing with some of the problems that you see inherently available. The other thing that is a real key feature of SMB 2 and 3 over the last few years, this is not new, but it's the concept of having multiple channels. So we've seen a lot more improvements. TCP itself has become much more capable of handling multiple paths. Well, in the same way, it was critical for SMB to enter the modern world and take advantage of multiple paths. And basically at the network side, from the client or server perspective, take advantage of those paths, aggregate that performance. So some of those talks you'll see at the SNIA events cover some of these and give examples of how the throughput increased greatly. And of course, by nature, your tolerance of a problem on the network increases if you have another path of delivery. And hopefully, your implementation will have a quick configuration that'll make it easier to use. 3.0.2, the only reason I mention this is we did implement Microsoft originally implemented a scale-out file server cluster. Many of our other SMB implementers that I've talked with you over time, everyone has a slightly different clustering implementation. That's not critical. the protocol itself is not dependent on how the clustering is implemented necessarily. So keep in mind that when I refer to some of these things that Microsoft has indicated, so scale out file servers, for example, you'll see somewhat of a different environment in the Samba environment, and that's just fine. Some of the other implementers as well have implemented their clustering in a particular way. The direct remote invalidation was implemented in the transport as well. As I mentioned, RDMA is a key performance capability. There are a couple of other highlights that I wanted to make. One of the ones that has now become, the areas has become of interest is the HyperV scenario, the hypervisor scenario, storage over SMB 2 and 3. Again, that's what IBM was highlighting for interest in the Cinder Manila areas for OpenStack in this last year, how critical it is to build that infrastructure. So one of the areas that Microsoft uses is the HyperV as a hypervisor. Just as we just mentioned for your OpenStack environment, you would want to have a high-speed delivery of storage for the virtualization layer. And Remote Shared Virtual Disk Protocol has been implemented as a way of extrapolating, delivering your SCSI commands over a SMB 2 and 3 transport. So this is another, what would be an evolution in that area. So just to be aware of that. Again, this is not brand new, but it is something that is, you'll notice when I talk about it in the software-defined storage areas and what Microsoft is now implementing in our next releases, Server V Next, that this is one of another piece of that plumbing. So extending the negotiation, there were a few reserved bits, and I will say the process of negotiation is somewhat complex. I won't try to go into this in great detail, but just to highlight that there were a couple of bits, the pre-auth integrity capabilities and encryption capabilities for SMB2. Those bits are now being used, and just to be aware of this, I won't get into this in any great detail, but I did want to mention that this is part of the overall SMB2 protocol implementation. The client cluster failover was a concept that, again, when you have a share, it's going to be critical to have access to more than one path in order to provide some sort of a failover implementation. So this is just giving an example for a SQL storage, your data on the back end for SQL. It could be for your hypervisor, but in any case, you're going to want to have the capability to fail over. So one of the terms that is very commonly used in SMB 2 and 3 is the continuous availability, or the client failover. And so you'll see that referred to. In fact, it's a requirement for HyperV. In particular, when we document requirements of the SMB 2 and 3 protocol that are implemented by the storage community for those specifications. So this is critical to have this failover capability in some manner. And then you'll end up with a file sharing violation. There is a fencing capability which has to do within the Microsoft world. I'll mention in this a little bit. Basically, there is an issue where you are required to, because of the way Microsoft is implementing our current clustering, you're going to be dependent on having a matching level of those cluster nodes. So just for the purpose of having mentioned that it will look for a tree connect to a similar level of the SMB dialect. I did want to highlight a few of the things in SMB 3.1.1, which is what our Windows 10 implementation and Windows Server v.next will be including. So this is included at the 3.1.1 dialect level now for SMB. The extensible negotiation, I mentioned there's a few bits that are in use for this capability for pre-authentication. This signing has been improved for security, but there's also a new level of encryption and a key exchange process that has been provided, which provides a greater level of security. And again, an improved layer of the cluster client failover that we mentioned for continuous availability on the storage clustered side, and the dialect fencing, which we mentioned, which really comes down to the fact that you cannot support a clustered environment built on mixed versions of at least in the Windows world. Again, some of that becomes a somewhat of in protocol world we have musts and shoulds and mays. That is not a must. Whereas some of these others, such as encryption improvements and the failover, those are definitely must implementations in order to get those capabilities. So from a security analysis point of view, as we said, one of the reasons, starting with the red at the bottom, one of the reasons that SMB1 is part of the history is the level of security that it provided. In particular, in signing, there were some key attacks that could be made for the man in the middle during the signing, which 3.0 improved upon, and you'll see that 3.1.1 has an improved signature process that is more secure as well. There is a note here, and this is just for your reference, that the pre-auth integrity can't protect anonymous or guest sessions. It is reliant upon the actual authentication process in our Kerberos world or others still using NTLM that you'll be familiar with. So I've provided a brief overview of the pre-auth integrity negotiation process here. There is a slide for reference in the appendix if you're curious a little bit more about this. But just to highlight one thing is that in 3.1.1, in 3.0, the top levels during negotiation and session setup, there were some protections of the signing process, but in 3.1.1, with pre-auth integrity, it added the full process all the way through when session keys, the secret keys, are used for the session setup and the final tree connect process as well. So you'll avoid tampering by going through the full process under 3.1 and 3.1.1. So SMB encryption has been in place for some time, but with 3.1.1, this is a stronger encryption, 128 AES, that you'll be familiar with. This is, there are some improvements in performance, but primarily the process of negotiating per computer session, so that this is no longer, I guess you could say, that in some ways this is a side effect of Snowden, right? The per session key concept is a standard now in the security industry. Perhaps a good thing that came out of the whole Snowden experience was an increased awareness of how important those keys are as far as they not be used globally or reused for an ongoing process or stored. So Microsoft software-defined storage, built upon a bunch of disks or other nodes for your cluster at the bottom layer. So the purpose of this slide is to show you, we've talked about the SMB 3.1.1 protocol, the newer updates, and the protocol in general. Now you'll see that these protocols that have been developed over these last number of years are actually being put to use, as we said, in the industry for building, not just for building a Microsoft implementation, but across, there's interest, as we've said before, IBM and others, interested in how you would build a private cloud for an OpenStack environment. You have a number of requirements to do that, and what we would describe that in not just Microsoft terms, but in the industry as a software-defined storage environment. So building from the ground up, starting with the basic disk storage in nodes of your cluster that are pooled, and then finally what we would call in Microsoft world would be spaces and shared, which we're all very familiar with in the SMB world in a shared environment. Finally, using our SMB3 plumbing to tie this all together. So when we develop this scale-out file server for a clustering implementation, it's all based on these standard SMB3 protocols. So it'll be very similar. You'll see the analogies that will be very similar to you in the industry that Microsoft is also doing and implementing in our current releases. The advantages, again, we said you have to have a high speed or low latency network implementation to facilitate the storage environment for a cloud. You will not simply use an old basic Ethernet environment with a single path. And you'll want to have a tiered storage implementation. Those of you in the storage industry are implementing your tiers of storage. It's a very standard concept to do that. You want to have resiliency so that when your storage is implemented, if one of those clusters fails, you want to have a quick method of failing over to another target. And the client has to be resilient and capable of having continuously available storage to it that it can fail over to. So these are all concepts in this software-defined storage environment. So if you understand those basic principles, you'll begin to realize that, well, why have we implemented all of these things in the SMB world in these last few years? It now becomes very obvious that these are key fundamental principles that must be available in order to implement a private cloud. So you may do something a little bit differently. Certainly you can do the same in an NFS world in some cases. But now we begin to see how the SMB 2 and 3 protocols have provided a full suite of these capabilities to allow us to build that software-defined storage, which again is one of our foundations for building a private cloud. So the scale-out file server, again, is simply a concept that we would have our shared volumes and going across an active set of file shares, scaling across our multiple targeted storage cluster volumes and providing you with zero downtime capabilities with a successful and reliable failover, and finally recovering when there is a failure, and targeting this application, this storage for particular applications, your hypervisors, your storage for your databases or SQL in those cases. So SQL being a consumer at the application layer, and then again HyperV. So as we said before, we're building a private cloud, aren't we? So in order to build that cloud environment, finally we're just serving it, we're providing the plumbing that serves ultimately to these applications, the critical applications that Julian and others throughout this session will be talking about. And another fundamental concept of transparent failover between our nodes in our cluster must be provided in order to provide reliability for our storage and served up to the application layer. So if one of those shared volumes on the node, one of the nodes is not available, you have to be able to fail over. So this is a key fundamental concept. Again, this is a may in our protocol implementations, a should. In other words, it's not, the fundamental capability of continuous availability is a must, and it will be required in order to implement this part of your cloud. How you do it, in this case, this failover, the Microsoft implementation would be a should. In other words, you'll find that there are various ways that have been implemented in the industry to do that. But again, back to the requirement at the bottom, the resiliency that is provided for that clustered service. The witness protocol is something that proactively monitors those paths that are available to the nodes, and in the cluster will proactively make sure the status of those and provide a ability so that as a client, the client knows what the status of the nodes are in the cluster and how it can fail over more quickly. So this facilitates a quicker response. And again, this will notify the client to do that. And so Microsoft has provided an open protocol, the SWN, the witness, as a supplement. And this is part of our SMB 2 and 3, what we call protocol family, or family of protocols, open protocols. So this witness protocol facilitates this failover capability. Just to mention briefly, on asymmetric scale-out file server clusters, I won't get into this very much, except there is a reference here to our blog, Jose Barreto's blog. He is actually one of our very useful references. You'll see that he has a good set of references on the SMB protocol from a background standpoint, where we're going with moving on to SMB 2 and 3. In this case, you could refer if you wanted to know more about the asymmetric scale-out file server cluster implementation itself. This is one of the new updates that you'll see referred to in the share capabilities returned, and it does register the witness. So going under the hood a little bit for software-defined storage, I did want to provide you one snapshot. We talked about the disk subsystem at the lower level. Commonly, you'll see just basic SAS or SATA in many implementations, and then a software storage bus. This is a basic concept in what we're going to hear about as a software-defined data center environment. And Microsoft calls these storage spaces for pooling these disk resources, and again, providing a resilient environment, another requirement. So for the file system, you'll hear referred to as REFS, the resilient file system from Microsoft in recent times, which is being used for the VHD recovery under HyperV. The storage, access, and scale-out file server, again, as we referred to, is the fundamental basis for concept of providing a resilient environment. So just to provide a basic description, you heard a little bit about the Azure services that are being delivered. One of the services that's being exposed, so if you have a Linux client, a Red Hat or Ubuntu, you can share files. Just as Apple has now gone to SMB2 for sharing files by default, in the Azure environment, we're going to continue to use SMB. So when you connect with your Linux client in Azure and you can share files to the Azure file services, you're going over an SMB 2.1 implementation. So interestingly enough, the Azure implementation is just another implementation, just like Samba or any other, that is built on, in this case, SMB 2.1. Expect more updates, in particular at our June event, about what Azure is doing, and they're reaching out to us to engage with you, and that's one of the reasons I'm mentioning it today, is they've asked us to engage more. We're working with some of the folks on Samba team, for example, that they've done some testing over time against Azure, provided key interoperability feedback, so that's been great, and we've also helped with the Linux kernel changes for the Linux client that were needed as well. So there is a document here at the bottom which gives you some of the exceptions to the SMB2 and 3 protocol that are simply not supported. This is not a Windows implementation. It is Azure's file implementation of SMB. So I've talked very briefly today with an overview of some of the SMB2, 3, and 3.11 protocol implementations and how those are referred to in Windows 10, Windows Server v.next. By the way, I think I should at least mention, you've probably seen Microsoft has talked about the cadence, Windows 10 this year shipping, but as a client, but the server is not shipping this year, so the vNext is coming in the future. We'll worry about that. But for now, you've seen, again in April, the protocol specifications are being published in an open fashion, particularly for SMB2 and 3. So you can refer to those protocols and see the changes that are being reflected in the products for Windows 10 and Windows Server v.next. And you'll see this again in another approximately quarterly cadence moving forward. So these specifications will be available to you. So I did want to highlight that as one of our key references on our open specifications library that Michael referred to earlier. So highlighting those key resources available. Another item that's available, Michael had put on the slide for us this morning, those protocol test suites. So when Microsoft has developed our documents, we have tested them with our protocol test suites, and we make them available to you during these events. And I wanted to highlight that our new SMB2 and 3 test suites will soon be delivered as open source. We're in the process of shipping the framework in a few months, along with the early SMB implementation of 1 and as crawling. And yes, we will actually open source those so that as requested, you can contribute back to them through the manner of using GitHub, for example, in a familiar fashion with a familiar open source license. Look to our events. Presentations also made available on at the location below. So again, I mentioned that we're going through the open sourcing of the test suites. Bear with us. I know it's been a bit of a delayed process. We've intended to do that for some time, but we're actually doing so this year. And currently, as last year, the MSIs are available with source code for your reference you can use today for your interoperability test purposes. So those are the things I wanted to present to you. Hopefully, this is a helpful reference, a set of tools that you can refer to. Questions? Any questions about our tools or the protocol specifications? As I mentioned earlier, one of our primary purposes for being here is to gain your feedback, whether it's for those tools, for our specifications. And again, please take advantage of our support engineers, Obed, and others, our test team resources, technical resources that are here this week. Ask questions. We'll be here, and we want to take that feedback. So thank you.
I have a question.
Yes.
I have a question. This might be stupid, but you presented the new protocols of SMB 3.11.
Right.
Basically, the improvement is all about security, right?
It really is. It truly is. The primary purpose of updating 3.11 for SMB 3 protocol really revolved around security. The encryption, stronger encryption capabilities, and the signing capabilities. There were a few other minor ones, but primarily it was around security.
So my question is, if I have a cluster of several nodes, some of them implement only some SMB3, and some others implement SMB 3.11, what happens?
Well, that's a great question. Remember we talked about the fencing capability that Microsoft has, which is another implementation of SMB. Samba is not required to do this, but the way Microsoft has done it with the fencing is they do require that those nodes be at a certain level. So they really all need to be up to date to 3.11 for that to gain that functionality. And there is a methodology in the, I won't get into it in detail, but there's a thought process for if you're deploying that there is a requirement, and it facilitates how those servers roll out, and so they're required to be brought up to that current level to be participating. So, and again, that's a should. The must is to implement those security capabilities and resilience and failover, but the should is they should be consistent.
Mhm.
Yes, Chris.
So just, Darryl, correct me where I'm wrong here, but my understanding,
Yeah. So we can have your question recorded.
Thank you much. All right, Darryl again. Oh, okay.
Yeah.
Again, correct me where I'm wrong here, but my understanding too is that when you're dealing with a cluster over SMB, the initial connection is one client to one server node over one path.
Right.
And all of the protocol negotiation, including the version of the protocol that you're choosing, occurs then and there. So in order for a mixed cluster like that to work, they would have to be serving different virtual servers, because the different virtual servers could be at different levels. But an individual server, you connect to it once and you negotiate a protocol level, and that's it. That's where you are. So even though you have multiple connections, they all have to be at the same level.
So, and again, to clarify, this presentation was meant to provide you with an overview. There's a whole series of more detailed discussions that are included in our last June event. We've covered a number of these issues in far greater detail from the developers themselves, Tom Talpe and others. So as Chris is explaining, there's really a lot to these protocols, not just for clustering, but for security and other capabilities. So look for our recordings from Tom, David Cruzy, and others. So, yeah, and come to Samba XP next week, yes.